Hello, everyone. Good afternoon. Before we begin, please confirm that you can hear me and see the slides clearly by just typing yes in the chat window. Also, we would like you to introduce yourself, the company you belong to, designation, and the country you are based in. It's a pleasure to see an international audience of people from all industries and backgrounds in all the webinars that we conduct. So it's really good to see you all. And thank you so much for joining and confirming. I would like to thank you all for registering and taking time out on a Sunday to learn about hazardous area classification in accordance with EI-15, IP-15, and API 505, along with the selection and installation criteria of E&I equipment and hazardous area classification zones. My name is Aisha Khalik, and I will be your introductory speaker for today. It's our pleasure to host this webinar for you. This is our 87th webinar in a series of technical webinars that we are conducting. As a practice, we are conducting one webinar every month. So please follow us on LinkedIn and YouTube and make sure to check our website for the latest updates so that you do not miss out on our webinars. Today, we have an experienced panel of speakers. I am with my colleague, Mr. Ijazul Karim Rao, who's Managing Director, Principal Integrity and Safety Consultant. Then we have Madam Mubina Khatoon on board. She's Director, Engineering Services, and Mr. Anthony James William, who's General Manager for Global Sales. Moving forward during this webinar, we encourage you to ask questions to clear any doubts that you have. We would definitely like your engagement on this topic. You can type your queries in the question and answer window, and you will receive a reply in the Q&A window, or we can take your answer live. We will try to answer questions as much as possible during this session. As we will have a detailed question and answer session after the completion of the topic, please accept our apologies if your question is not addressed due to high volume of questions that we generally received during the webinar. So we have to be selective. Furthermore, we will also be issuing participation certificates to all those who have attended at least 80% of the webinar and who has participated in the discussion through question and answer. Since this is a quite technical subject, and we will touch only theoretical and practical aspects of hazardous area classification in accordance with EI-15, IP-15, and API 505, along with the selection and installation criteria of E&I equipment in hazardous area classification zones. In this limited time of 2 hours, we request you all to follow along with us and keep asking questions to help us make this session as engaging as possible. So before we begin, let's have a quick safety moment. Although most of us are in the comfort zone of our homes, we should be aware of emergency exits. You should keep a safe distance and generally take care of ourselves and those who are around us. Now, Mr. Ijazul Karim will start with today's topic in a while.
Good day and Assalamu alaikum. It is the afternoon in Abu Dhabi and evening in Malaysia and very early morning in America and morning in Europe. So today's topic is quite interesting one, and it is useful for everyone who is dealing to take any equipment inside the process plants, or if we need to maintain, like I was just discussing, like hazard area classification or hazardous area classification is a very common terminology, and it is used if, for example, if I need to carry a mobile phone inside the process plant. So question would be whether my phone would not be acting as an ignition source and should not ignite the fire at the plant. Similarly, if any electrical and instrumentation equipment is being installed inside the hydrocarbon facility, so what should be the type of that equipment as long as explosion-proof nature is concerned? Similarly, if I need to carry any vehicle in a engine-driven crane inside the plant, then how I can take that, right? So this is the challenge. So hazard area classification is very much common and commonly used terminology. However, how it should be done, and what kind of basic knowledge is required. So today we will be discussing that. So there was high demand for this kind of webinar or training course. So we feel that we can contribute in this particular field, and so as a as a return, we are having a lot of business from the industry, and we're also conducting many paid training courses. So some training courses we can conduct at the expense of Velocity and for the contribution toward the newcomers and so on. So coming back, the objective of this webinar is the as I said, how we can equip the attendees with the understanding of parameters that determine the degree and extent of hazardous locations. Then in this webinar, we will focus on locations where flammable gases or vapor, flammable liquids are processed or handled, and where their release into the atmosphere could lead to ignition by electrical system or equipment, even instrumentation system and equipment. The webinar will cover the selection and installation of electrical and instrumentation equipment in HAC zones. Then additionally, in this session, we will also present a case study to illustrate the application of HAC fundamentals in real case scenarios. Now, HAC. Hazardous area classification is a method of analyzing and classifying the environment where explosive gas atmosphere may occur, and presence of any ignition source in that vicinity may cause fire and explosion. This is what I explained in the beginning example. Then HAC objective. The objective of hazard area classification is to facilitate the proper selection, installation, and operation of electrical and instrumentation equipment so that these equipment may not act as a potential ignition source in the process plant or warehouse. The HAC process also involve hardware-based or procedural control of hot surfaces or hot work in the process areas. As I said, it's not like an electrical equipment, motor or a switch gear or a junction box or a cable termination point, or there could be a transmitter or any kind of instrument which is available in the plant that may act as an ignition source due to stray current, due to the voltage or due to the current available, or spark might be created. But there are other things as well, like a vehicle entry. A vehicle is having exhaust. That exhaust may also act as a ignition source. So in general, vehicle with diesel engine are allowed to come inside the process areas. With exhaust, there should be some absorber on the exhaust as well. Similarly, if any work has to be done with the flame, there should be a proper hot work permit or a procedure control is also required. Similarly, in general sense, we know that why hazard areas classification is necessary. We know that we're talking about hydrocarbon areas or process plants where gas or oil may leak anytime, and in the environment there could be some hydrocarbon. If they are reaching to the LEL limit, and if there would be any ignition source or a spark, then that area may get fire or may explode. So that's why hazard area classification is required, so as we can avoid or we can control that kind of threat. Why? If you see that in normal, we know that there is a fire hazard triangle. In fire hazard triangle, there are three things. Number one is a fuel or a flammable gas. Number two, oxygen, which is available in the air anyway. Then third thing which is missing, that is the source of ignition. So the objective of HAC is this triangle should not be established. If this triangle is established, then there might be a fire and explosion. And there's a lot of capital investment in these process plants. Secondly, there are people around, there are population around, and it may cause the disaster. So that's why, to eliminate the one important angle of the fire triangle, we try to remove or control the source of ignitions. So the reference standards, like which are available to go by or develop like HAC process. Previously, the standard was IP-15. Now the new name is like Energy Institute 15. Then EI part 15 we normally call it. Then part 1 is there, API RP. Previously there was a 500 and then 505 was introduced. These are two American standards. So IP, normally people who are familiar with hazard area classification in past, IP-15 and API RP 500 were compared. Now, American have developed also API RP 505, which is comparable with IP-15 or EI-15 or EI Part 15. So similarly, NFPA 497 and NFPA 499 are also a guideline for the HAC classification. So then if you go to IEC, there is problem sound-wise?
It's all
Okay, now if we go IEC 60079, part 1 to other parts, till part 29 and above, these are the basically standards. What like 60079 is for the selection of electrical equipment, like or the explosive equipments which could be installed inside the process facilities. So these standards, like if we say IP-15 mean model code for of safe practice, part 15 area classification for installation handling flammable fluids, then part 1 selection, installation, inspection and maintenance of electrical and non-electrical apparatus in the hazard areas. So it means if part 15 and part 1 are combined, it covers both like hazard area classification process as well as the selection of E&I equipments. Then 505 is a recommended practice which use the same terminology as of basically IP-15. Then API RP 500 and other standards, right? Now, if we try to see these standards, what is covered there? This is IP-15 or part 15. So here, what we normally go through, the technique for area classification, the point source approach for classification of individual source of release, then effect of ventilation on area classifications. Then their appendices are also their classification and categories of the petroleum and flammable fluids. Then area classification for hydrogen, calculation of hazard radii, then direct example approach, then small scale operations and so on. So this standard, basically, if I say we have been using for a long time and it's quite basically easy to use standard. Next one is like API 505. This is a recommended practice for classification recommended practice for classification of locations for electrical installations at petroleum facilities classified as zone class 1, 0, 1 and zone 2. And here the information is also similar. For example, flammable and combustible liquid gases and vapors, then classification criteria, then extent of classification locations, and then recommendations for the determination of the degree of the extent of the classifications and so on. So these standards are self-explanatory and very easy to use if you wish to follow it. Next, NFPA 497 is the recommended practice for classification of flammable liquid gases or vapors and or hazardous classified locations. So this is also similar to other standards, but more difficult to use. NFPA is more difficult as compared to IP-15 and API 505 or API 500. Then this is the standard which is for the selection, is more commonly used standard, IEC 60079 for classification and selection of the electrical and instrumentation apparatus. Now, who like some people are raising hands, I would say add your questions in the question, like
yes, question and answer tab.
Question answer tab, and we will be taking the question answers as the half part of the presentation would be over. So keep writing your questions because your participation is very, very important for us. And it will be more useful for everyone because we will have a interactive question and answer session in the middle as we are used to do before. So that would be done. So like which people are normally, basically engineers are doing this part. Like as per my experience, any engineer under supervision of a senior engineer like me and others can learn and work on hazardous classification very easily. I have led or trained many people in my organization, and it's not difficult to do, but yes, normal determination, normal hard work, normal basic knowledge is required. So in general, process engineer or chemical engineer, petroleum engineer, or any mechanical engineer can also do, but he should be able to read the standard, understand the standard. Then profession-wise, HSC or safety engineers, then they are for the hazard area classification. Then E&I engineers are required. Basically, they are selecting the electrical and instrumentation equipments, their data sheets, and their kind of selection or the classification to install those equipment in the relevant HAC class. Now, as we have spent some time now, but at least we should be knowing certain terminologies which we use during the HAC process. Though number one, hazardous area, a three-dimensional space in which a flammable atmosphere, or it may be expected to be present in such a frequency as to require special precautions for the construction and use of electrical apparatus. All other areas are referred to as non-hazardous in this context. Then non-hazardous area, like a three-dimensional space, if any hydrocarbon is not, or flammable material or dust is not present, that is called normally non-hazardous basically area. Like we say process area and utility area. In the utility area, except the fuel gas area where the hydrocarbons available, but if you take a fire water, you take nitrogen, if we take other utilities, then those are called normally non-hazardous areas. So flammable liquid, what is a flammable liquid? Like anything which can catch flame is called a flammable liquid. It got various classes, class 1A, 1B, and 1C, and it is related to the flash point. If flash point is below 22.8 degrees Celsius, this is a class A. If between basically 22.8 degrees Celsius and boiling point at or above 37.8 degrees Celsius, class liquid 1B, and then any liquid that has a flash point above 22.8 degree but below 37.8 degrees, that's called class 1C liquid. And those liquid, when you identify these are selected for the area classification and for the selection of the relevant electrical instrumentation apparatus, if that would be installed in that area. Similarly, these categories are further categorized as fluid category A, B, C. A is further, if you go back, A is divided 1A, 1B, 1C, and then there's also class A, class B, class C, and G1 and G2. For example, a flammable liquid that on release would vaporize rapidly and substantially. This category include any liquid petroleum gas or lighter flammable fluid. Then any flammable liquid at atmospheric sufficient to produce or on release more than about 40% volume vaporization with no heat input other than from the surroundings. Then fluid category B, a flammable fluid liquid not in category A but at a temperature sufficient to boiling to occur on release. Then category C, a flammable liquid not in category A or B but which can or release but be at a temperature above its flash point. Then typical methane-rich natural gas is G1, and then refinery hydrogen is G2. Similarly, the combustible fluids are also classified as like class 2 liquid, class 3 liquid, class 3A liquid, class 3B liquid. This is the same temperature limit as we explained earlier. Similarly, the flash point, as according to NFPA 497, is defined as the minimum temperature at which a liquid gives off vapor in sufficient concentration to form an ignitable mixture where there near the surface of the liquid is known as flash point. For example, for ethanol, 16.6 degree Celsius. So it means that like if alcohol, a normal drinking alcohol, if it is 100% like even it's a beer or whiskey, if it would have a higher content of ethanol, it may catch fire. And then gasoline at minus 43 degree C. Diesel is the flash point is above 52 degrees C. Jet fuel is above 38 degrees C. Kerosene is above 38 degrees C. Whereas ethanol or normal alcohol got a flash point at 16.6 degrees C. It means it can catch fire easily in summer. So ignition or auto ignition temperature AIT in accordance with API 505. Some definitions we are bringing on various codes so as we can get the relevant data or understanding. So in accordance with API 505, the lowest temperature of a heated surface at which under specified condition, the ignition of a flammable substance in the form of a gas or a vapor mixture where there will occur is called auto ignition temperature. Ethanol auto ignition is 363 degrees C, gasoline 246 degrees C, diesel 210, jet fuel 210, kerosene 220. If you see that the fuel like lighter and their auto ignition temperature is higher, that's why gasoline engine are normally called basically auto like ignition like with ignition switch engines, whereas diesel engines are normally called combustible ignition engines. They don't need a ignition switch to start the engine in the beginning process. Similarly, according to EI-15 or IP-15, there is LFL and UFL. LFL means low fuel, like a lowest concentration of the flammable gas or vapor in air at atmospheric pressure capable of being ignited. And the concentration of flammable gas or vapor in air at atmospheric pressure above which combustion will not occur because oxygen concentration would be lower at that time. It means for methane, it is 5%, ethane is 3%, propane is 2.1% in the air, butane 1.6%, pentane 1.5%, hexane 1.1%, heptane 1.05%, gasoline is 1.4%, naphtha 1.1%, kerosene 0.7%. And higher range is also given where the ignition will not take place. Then grade of releases, like how this hydrocarbon would be coming into the atmosphere. Continuous mean a release that is continuous or as expected to occur for a longer period. Then primarily mean a release that can be expected to occur periodically or occasionally during normal operation. Then secondary is a release that is not expected to occur in normal operation, and it does occur, is likely to do so only infrequently and for a shorter period. A source of release may give rise to any of the above grades of the release or to be a combination of more than one together. Similarly, now we go to the zones which we normally discuss. As per these zones are as per IP-15, zone 0, that is a part of hazardous area in which flammable atmosphere is continuously present or present for a longer period. Like zone 0, like inside the fluid. Like if a tank filled with the diesel or kerosene or any other hydrocarbon, zone 0 would be applicable in any electrical stimulation item which would be installed inside the tank should meet the requirement of zone 0. Then zone 1 is above the tank where a surface where there could be a potentially presence of the hydrocarbon for a longer period, but not continuous. So that part of hazardous area in which a flammable atmosphere is likely to occur in normal operation. Number 2, like not present all time, likely to occur. Then that part of a hazardous area in which a flammable atmosphere is likely to occur in normal operation, and if it occur, it will exist only for a shorter period. That is zone 2. Now, other part, as a terminology point of view, the NFPA 704, there is a diamond concept. That diamond concept is like the system of making shall like if any fluid MSDS, material safety data sheet, in that MSDS, these 4 questions are normally answered, like first is the flammability, then health impact, then reactivity. Yellow is reactivity. And like here we are saying health, flammability, instability, and instability sometimes also called as reactivity. Then blue for health hazard, red for safety or flammability, and yellow is for the reactivity. So in MSDS, all material are categorized as per this diamond, and accordingly their handling procedures are managed and developed. Then like this, if you go next stage, so there are some numbers which are defined like a 2, 4, 3 in each area. 4 is the highest and 0 is the minimum hazard. Like for example, if a fluid is given category 4, it means is the highest flammable. Then similarly, if reactivity wise also is a 4 mean very reactive material chemical. If it go to atmosphere, it can react with other chemicals very fast. So this is also understanding of MSDS table, right? Like how this diamond work. So this is also useful information. So after completing this, for example, after going through the basic definition, then which are the standard? The standards are like IP-15 or EI-15, then API 505 or API 500. These standards are more important than IEC 60079 for electrical instrumentation apparatus or equipment. Then also there is a IP or EI part 1 is also for the selection of the electrical and instrumentation equipment. Now, if we try to compare EI 15 zones, zone 0 and zone 1, if I try to compare, so zone like this part, zone 0 and zone 1, and then we compare also API 15, like this is a zone 0 and zone 1 also. So zone 0 we also already defined earlier. This part of hazardous area in which a flammable atmosphere is continuously present or present for a longer period. Then if a definition point of view, if we take zone 0, location in which ignitable concentrations of flammable gases or vapor are present continuously, or in which ignitable concentration of flammable gases or vapors are present for longer periods. So zone 0, and here we call division 1. Practically in API 500, zone 0 and zone 1 are combined under division 1. This is the difference. Whereas EI 15 and API 505, the zone 0, zone 1, zone 0, zone 1. And then if you go zone 2, then it's called division 1, division 2, and zone 2. This definition I already covered earlier. Means if I have to say zone 0 inside the fluid, and zone 1 where fluid can be available anytime, it means about 2 meters above the any equipment, vessel, pump, or tank. And then this area where sometime hydrocarbon may come, and this area is covered up to 15 meters from the equipment, and the different boundary limits are provided. So here again we are coming back the definition of EI 15 and API 505, like continuous grade release, primary grade release, and secondary grade release. It is like our release, like a release that is a continuous or nearly so, or that occur frequently and for a shorter periods. Then a release that is continuous or is expected to occur for a longer period. So definitions wise, EI 15 and API 505 are very close. And if you follow either practice, result would be more or less same. Now, if we see the comparison of the like a HAC, how we make this shading. So in general, if you see zone 0 is a dots, then zone 1 is a double cross, and zone 2 is a single line, if you see this. Similarly, if you go 505, dot, cross, double cross, and single line. So like a European code, which is EI part 15 or previous IP-15, for we take example of fixed roof, and also we're taking example of fixed roof. So here if you see, this is the above the liquid surface. This is the zone 0. Then up to 3 meters if you see, and from the top of the tank to bottom 2 meters. So this is the zone 1. And then below and up to dikes, and this is the dike. This is zone 2. Similarly, this is the same configuration is there in API 505. If you see here, zone 0, then zone, this is the difference here. They are taking like up to 3 meter and up to dikes, zone 2, and zone 0 here in the IP-15 or EI-15, they did not show the breathing valves, or there could be like some like breathing valve normally are nozzles on the top. If the breathing valve, they're marking the node up to 1.5 meter, and then up to 3 meter, they are marking the zone 2, 0, zone 1, and zone 2. Similar is there, they are saying as division 1 and division 2. Like here, this and this part, like zone 0 and zone 1 in these two standards are called as division 1 in API 500. This was the old concept. And then American API Institute issued another standard, which is 505, to make its system comparable with the European countries. The explanation I have given is the same explanation which is we explained in the previous picture. It is just a descriptive, and this is for the sharing as a presentation if we have to share. Next, take example. This is basically for the pictorial comparison EI-15 versus API RP505 versus these standards, and this is for the floating roof tank. If the floating roof above the tank, it is zone 0, then here is the zone basically 2, and some part zone basically again zone 0, right? Zone 1 is floating roof is not marked. Zone 1, zone 0, zone 2, zone 0 is not marked. Same is here. If you see zone 0 is there and zone 2 are there, and but zone 1 is not evident because that's against the nozzles. In floating roof, there's no like a breathing valve where the hydrocarbon may escape. At the near to mechanical seals outside, there could be a question. Sometimes mechanical seal does leak, but if any instrument or electrical item would be installed inside the tank above the floating roof, on the sides, on the mechanical seal, where like strips are there, so in that area there could be some impact. Anyway, this is the drawing which is available in API 505, API 500, and IP-15. Now, next, one more example, open sump, like a drain collection sump, like how HAC like a classification is done. The open sump is zone for like here if you see, here the liquids available is zone 0. Then above this H height, zone 1, and then this side up to 15 meter, this side, if you consider that node C, the open sump zoning for primary release, and this one is basically zone 1. Similarly, zone 0, zone 1, and zone 2. And here, zone basically division 1, and then this is basically division 1 again, and then division 2. This is the basically division 1 and division 2, and this one is shown as also as a division 1. So this is another example where a small like a bundled horizontal storage, if we take that, how the classification is shown. So this is the basically the legend or the guideline. Zone 0, zone 1, zone 2, always remember. Zone 0, zone 1, zone 2, then division 1 and division 2. And this as per EI part 15, this API 505, then API 500. If you go this standard, so these are the pictorial pictures available, and it does help us to show like where, like here, if you see, this one is zone 2, and this is the vent of the PSV, where up to 2 meter zone 1 is considered. Same is here, mostly zone 2, and then some area as zone 1. Here, everything is zone like a division 2, and some areas as a division 1. Division 1 and division 2, this is the area. If I see here, this, I think a wrong picture is there, I would say, because both should be division 1. Like this cross should be below. So there's a mistake in our presentation, we'll correct it. Now, if we try to ask a question to ourselves, and you can write your answer like in the basically chat box or in the chat box, like what is the difference between the hazardous area classification methods like in EI-15, API 505, and API 500. Like, what's the difference between the hazardous area classification methods? Like in EI-15, API 505, and API 500, you can write like a zone 0, zone 1, zone 2, or division 1 and division 2. So this answer is there. Like in EI-15 and API 505, provide a detailed classification system based on the likelihood and duration of the flammable atmosphere using zones, right? Whereas in contrast, API 500 use the division system, where division 1 encompass both zone 0 and zone 1 conditions, and division 2 covers zone 2, basically. So if EI-15 and API 500, zone 0, zone 1, zone 2, whereas API 500 only division 1 and division 2. So now selection of HAC approach. Like as per if we go, there are basically 3 approaches are there. EI-15 summarize. Now we will be mostly focusing on EI-15 or IP-15. Summarize facilities of standard layout and design. Handling fluid can be classified directly from typical example. This is referred as the direct example approach. This facility may also be classified using the point source approach, and risk approach is also there with the next, like a point source approach, risk-based approach, and direct example approach. So classification can be done by 3 approaches. Here, if I try to go example-wise here, let's say, for example, detail of installation plant or process. This is the important section now. If anyone would be doing classification based on this webinar, so it starts from here. Is the quantity of flammable material that may be released sufficient to require classification? Answer yes. Then we say, is the facility of common type? Like, can a petroleum class be assigned to the material? If no, for example, if the quantity of flammable material is that may be released sufficient to require classification, yes, then we have to go downside. If no, then it will go classification not required. Nevertheless, consider other safety measures, non-hazard area. So this is the last one, easy one we have done first, like where hazard area classification not required. Then if I go, can a petroleum class be assigned to the material? If yes, then we can do assign a petroleum class and determine the extent of hazardous area and zone classification using direct example approach. There is a direct example approach, then assign non-flammable petroleum class, classification not required, nevertheless, no, sorry. This is assign class, and then basically hazardous area, then we go to other 2. Direct approach, if we know the petroleum class, we can also apply this. Normally, we follow the combination of direct example approach and point source approach. Like combination of both is there. Risk-based approach normally not followed because it is a qualitative, and qualitative risk approach may misguide you. But this approach can also be used. So here, if I go back, like detail of any installation or plant or facility, is the quantity of flammable material that may be released is required classification? No, then non-hazard area classification. If yes, is the facility of common type? If yes, then we go to, can a petroleum class be assigned? Yes, assign petroleum class, and we can go to direct approach and we can do hazard area classification. If no, then we go to bigger process like a material properties. This is normally what we follow. Material properties of all the fluids which are contained by each equipment in that particular area. What is the boiling point? What is the flash point? Ambient temperature. Process condition like pressure and temperature. And then, is the fluid at a temperature below its flash point? Can the fluid form a flammable mist at these process conditions? And so on. So if they say, can the fluid form a flammable at these process mist conditions? No, then classification not required. If yes, then we go back to this side. Assign fluid category. Is the release rate known, hole size or pressure? Then determine the extent of hazardous area and zone classification using point source approach, and determine the extent of the hazardous area and zone classification using risk-based approach. So 3 approaches: point source approach, risk-based approach, direct example approach. And then other 2 are the how you can exclude. So This is the basically methodology given, and normally we will be explaining more on the point source. So same thing what we explained. Now, point source approach, we are in 32 slides here. Like this is the how we normally do, but it's a combination of, as I said earlier, I go back a little bit. I said direct example approach and point source approach, because normally we know if a crude is there, if a diesel is there, kerosene is there, it means we know the petroleum class, and then accordingly we can follow the direct example approach. Otherwise, we have to use the point source approach. Risk-based approach can also be used. So now we are giving example for the point source approach. In that, first of all, fluid-wise, continuous, primary, secondary. Continuous mean inside the equipment. Primary mean around up to 2 meters, 3 meters. Secondary mean where fluid can reach sometime. Other detail will also come. So source release, grade release, which is here. Then properties of the fluid, for example, petroleum class, fluid category, temperature class. Then ventilation, ventilation is normally applicable if the plant is like in the closed building or in the open building. Then HAC zones, zone 0, zone 1 or zone 2, extent of the zone, then hatching, HAC drawing, and then electrical or instrumentation equipment installation. So these are the practical steps for the HAC basically drawing preparation. If you see this, it's not difficult. If anyone would like to do themselves under any supervision of the senior, they can do, and very easy to follow this approach. Here, according to EI-15 or IP-15, a source of release is a point from which a flammable gas or vapor of the liquid may be released into the atmosphere. Possible source of release are valves, flanges. In valves mean their stem can leak, or glands may leak, then flanges may leak, vents are there, sample and drainage points are there. Instrument connections are also with the flange connections, like release from the rotating machinery such as a pump, mechanical seals or the impeller area or compressors. Then any area where spillage from these sources could collect. So in well-designed, operated and maintained facilities, such point sources are usually secondary grade release with a limited number of primary and continuous grade releases. So we have already covered this continuous, primary and secondary, means inside the vessel, around, and then secondary, always available, sometime available, and the random, rarely available. Hydrocarbon, which could be ignited by the ignition source, and we need to control the ignition source accordingly. Similarly, we have to see how much fluid would be coming out. In the case of operational control release, for example, sampling and drain point, most, if not all, vents, filter, cleaning, and pig receiving operation, no one grade of the release is applicable. Since the operational frequency chosen will determine whether the equipment release should be graded as a primary or continuous. Such a decision can usually be made at the planning stage. For release that are not operationally controlled, for example, accidental leakage from the equipment or secondary grade of release is applicable in that scenario. All accidental releases are called as secondary. And secondary mean we have to go level 2 or zone 2. Here, the definition is also given in the standard: continuous more than 1,000 hours per year. If the hydrocarbon is available, more than 1,000 hours per year. Remember, there are almost 5,000 hours are there in 1 year. No, 8,000 hours are there in 1 year. And so it's 1,000 mean like 1/8 time of the year. If hydrocarbon is available, that will be called as continuous. Then 10 to 1,000 hours per year is a primary. This is zone 0 as per IP-15. Then zone 1 and secondary 10 hours, up to 10 hours. This is basically called zone 2. Similarly, fluid category is also important while selecting the equipment. With the fluid category A, B, C, G1, and G2, we covered this in the earlier slide. It's just a reference for the working process. Then there's also petroleum class 0, 1, class 2, 1, class 2, 2, class 2, 3, 1, class 3, 2, and unclassified. Like here, if you see that, class 0 is LPG, then a liquid that have a flash point below 21 degrees Celsius and so on, the definition is given, and that we need to follow. So I have to take care of the time because of the 169 slides. If I try to cover every aspect, then time is more. So sorry for few slips. Here, then temperature class, this is basically class applicable when we select an instrument or equipment, like the surface should not be creating a temperature more than that temperature with the temperature class. For example, T6 is like a surface temperature of that particular equipment should not cross 85 degrees Celsius, right? And the T5, 100, T4, 135, and T1 is 450 degrees Celsius. Then ignition temperature of a gas or vapor in this particular case would be above 450, because in a hydrocarbon which may release in that particular equipment is also given, and the maximum temperature also allowed. So it means that auto ignition temperature of that particular fluid should be greater than that, and this is the temperature of any hot surface which could be in that particular hazard classification area. So ventilation, like what's the purpose of the ventilation? Like if hydrocarbons are released from any particular equipment or piping system, valve or vent, it should not remain present in that area. If it is accumulated, then it could be a cause of explosion anytime. So for the certain areas, we do apply ventilation. In open plant areas, plant are designed in a way there is a sufficient spaces are available inside the plant where air may provide ventilation, and hydrocarbon are not basically contained in that area. In like hydrocarbon which are released from the equipment, there are two types. One, like gases which are lighter than air, they will basically go above, and the gases which are heavier than air, like H2S, it would go on the undersurface. And so for both reasons, we need to keep a ventilation system. So here, procedure for assigning type and degree of ventilation, like first is the outdoor wise. In outdoor wise, we say that is there congestion restricting gas dispersion or air movement? If no, open area. For example, if yes, then is the area is stagnant or congested area or stagnant area 2, and then accordingly ventilation system is defined. Similarly, in enclosed areas, air movement limited and flammability atmosphere is not dispersed naturally. This is a problem. Does this enclosed area contain an internal source of release? If yes or no. If no, then this is not applicable. Like if there's no hydrocarbon equipment or storage, then no, and the external source exists, enclosure pressure should be greater than 50 PA. So then yes, overpressurized enclosure, and not means what? If you got a enclosed area, let's say a control room near the facility or substation, which is normally, let's say, substation does have its store like oil in the part of transformer in the switchgear. But if we take a control room, normally hydrocarbon not available inside, so it will not have any internal source release. So in that scenario, we try to make that building as a positively pressurized building. So in case hydrocarbons are released outside, those hydrocarbons are unable to penetrate into the building. So those buildings we need to maintain positive pressure. But if a point source is available inside the building, like if a warehouse or some other facility which is enclosed walls, then in that area, is there dilution ventilation? No. Does ventilation limit the average enclosure concentration, which is less than 25% LFL? Then yes, no, enclosed area, adequate ventilation is required. If no, enclosed area, inadequate ventilation is required, applicable. Then is the dilution ventilation? Yes, dilution ventilation is required. So in this way, since though we are not defining as a HAC preparation, people are not selecting what kind of ventilation is required. This job is for the process engineers or facility designers. Like if we got a hydrocarbon inside the facility or facilities outside in the open area, what kind of layout, what kind of ventilation is required? So this is also one of the important criteria while doing HAC classification. Now here, see the same thing, some discussion is there, like what kind of ventilation system or on zone classification for enclosure with an internal source of release. Effect of ventilation on zone classification for enclosure with an internal source of release. Great internal release source, continuous primary secondary, then accordingly inadequate or white. It should be like a zone 0, zone 1, zone 2, and then zoning of the remaining enclosed areas, zone 1, zone 2, and none. So here we need to basically establish the ventilation as per the applicable level of that zoning, what we need to maintain. For example, if we don't want to have like a presence of those hydrocarbons for a longer period, then the ventilation system should be a good one. And if we want to have like a longer we can afford, and then the installation of electrical and installation equipment, we have to maintain for the zone 0, which are very costly to maintain. So again, hazardous area classification based on the frequency of the occurrence and the duration of the exposure to atmosphere, we already touched it. Zone 0, zone 1, zone 2 as per IP-15, and also keeping API 505 in mind. Then zone 0, zone 1, zone 2, and unclassified, the typical relationship between zone classifications, like the time we are keeping in mind, more than 1,000 hours, 10 to 1,000 hours, and less than 10 hours, or unclassified areas there, less than 1 hour per year, if the release of hydrocarbon could take place there. Now, in accordance with NAP 497, class 1, zone 0, classified location include. Basically, this is definition of class 1, zone 0. It is the same, but definition wise, we don't need to go through this. But this is as per NAP 497, and NAP 497 is applicable in US, not in other areas. We are normally following the definition of basically IP-15 or EI-15. So other definition of class 1, zone 1. So we don't need to go through these details. This is just a theory, but if anybody would be able to keen, they can refer this section of 497 and get the required knowledge. The same definition what we covered earlier. Like if I go through this location where volatile flammable liquid or liquefied flammable gases are transferred from one container to another in area in the vicinity of spraying and painting operation where flammable solvents are used, this is called as class 1, zone 1. Adequately ventilated drying rooms for compartment for the evaporation of flammable solvents. Adequately ventilated location containing fire and oil extraction equipment using basically volatile flammable solvents and so. Then portion of the cleaning and dyeing plants where flammable liquids are used. Adequately ventilated gas generator rooms and other portion of gas manufacturing plants where flammable gas may be escaped. Similarly, like the definition of in accordance with NAP 497 class 1 zone 1 classified location include the following, same continuation is there. Then according with NAP 497 class 1 zone 2. Zone 2 is important. Zone 2 classification usually include locations where flammable liquids or flammable gases or vapor are used, but which would become hazardous only in case of an accident or unusual operating conditions. So now, what is the extent of the basically zones? Normally, we have seen in the diagrams also, like a full area, then up to 1.5 meters, up to 3 meters, up to 15 meters. So those are the extents. Now, extent of zone depend on the estimated or calculated distance over which an explosive mixture exists before it disappears to a concentration in air below its lower flammable limit, where the source of release is situated outside an area or in an adjoining area, the penetration of a significant quantity of flammable gas or vapor. Other area, like if a hydrocarbon may come from the neighboring areas, like a control room we need to control. Otherwise, we have a source release and how long it can extend. There are two parts. One, where hydrocarbon may release, flammable liquid may release from the point source. Other one is there is a neighboring facility from where hydrocarbons are released, and we have a facility where the same hydrocarbon with air or with wind can come and can penetrate to our area. In that area, we need to have a proper barriers, positive pressure inside, so as ingress of hydrocarbon into that particular equipment or that particular apparatus could be avoided. Then factor affecting the extent of zone mean like release rate of a gas or vapor, lower explosive limits, ventilation, other parameters like climatic conditions and topography. Then factor affecting the extent of zones, for example, geometry of the source of release velocity, concentration, volatility of the flammable liquid also important, like how fast and how long it will take, like the release material could make the dangerous, basically explosive mixture. Similarly, lower explosive limit of that particular fluid is also important. What kind of ventilation is there? Then that ventilation can also help to disperse the hydrocarbon release from that particular point source. Similarly, like other parts, for example, factor affecting the extent of zone, other parameter to be considered, climatic condition or topography mean the effect of the parameters. Some ways of above parameter affect the vapor or gas release rate, and hence the extent of the classified locations are like this way. Liquid temperature, for example, source release mean open surface of liquid. In most cases, the liquid temperature will be below the boiling point, and the vapor release rate will depend principally on the following: liquid temperature, vapor pressure of the liquid at the surface temperature, and dimension of the evaporation surface. Then the source release, like virtually instantaneous evaporation of the liquid, for example, a jet or a spray, open surface of a liquid. Since the discharged liquid vaporizes virtually instantaneously, the vapor release rate is equal to the liquid flow rate, and liquid flow rate depends on the following parameter: liquid pressure, geometry. When the liquid is not instantaneously vaporized, the situation is complex because droplet liquid jets and the pool may create separate source of release. So here, what we are saying here, we have to see certain simple examples are there. For example, a tank, we know tank, if a floating roof, then very less chances of vapor coming out. But if the fixed roof, then there are vapors on the above surface of the tank fluid, and there is empty space between the roof of the tank and the oil surface. There would be vapor there, and those vapor may also come out from the breathing valves. So that may also spread out. So we have to assess there. Similarly, if a pump is there, we have to see what happens if the like a mechanical seal of the pump fails. Similarly, if we got a pressure vessel, then on the nozzles or the whether it is a measuring apparatus, a BPCS, or the incoming outgoing fluid piping nozzles and flanges, they may leak. Then how much liquid may come out? So we have to do some judgment. But in general, it is easy to follow. There are typical examples which are available in IP-15 or API 505. Those could be followed to make the zoning on those particular infrastructures. Similarly, source of release leakage of a gas mixture. The gas release is affected by the following parameter: pressure within the equipment, geometry of the source of release, and concentration of the flammable gas. Mainly, the Bernoulli's equation plays a role here. If there is any potential leak, then pressure will drive the fluid, where pressure will convert into velocity, and velocity will be multiplied by time, and then distance covered in the given time. And that you will see up to what extent or up to what limit the fluid, or whether it's a hydrocarbon, gas, or toxic gas, may release and reach up to certain limits. So in this way, we have to make use of some sort of like a use of Bernoulli's equation and pressure to pressure and pressure head and the velocity correlation, and then what kind of point of release would be there, then accordingly extent can be understood. Now we are going to practical side, and there is some theory, even it's difficult, and we may not remembering all, but we should know the concept, and we should be able to reach to that area where if we need to have some extra knowledge, like how zoning should be done, what are the driving forces behind fluid, their nature, their flash point, their flammability, or their toxicity, their reactivity, and their diamond application or MSDS, those things we should know. So here again, these are the basically three categories which are used as per IP-15 and API 505, which is zone 0, zone 1, and zone 2. The HAC drawing, how we prepare, first of all, we take the plot plan of the particular layout facility. And if we have a 3D drawing, it's the best to have. Normally it is not available, so we go by 2D drawings and elevations, like one plot plan and one elevation, so as we can show the complete extent of the plant. Then we mark the boundaries of each equipment, and then accordingly HAC classification is started. Drawing should be kept up to date. Like one thing is there, whether it's as-built drawing. Sometimes it happens the plant has been modified and you are making HAC drawing on the old version. And sometimes you have made the older HAC drawing, and then plant has been modified, and you have to update the HAC drawing as per the newly installed equipment. So what do we need to take care? New or modified equipment, change in the installation, which we need to protection, then experience in operation of the installation, change in the method or frequency of operations, reclassification as a result of measurement in the around the hazardous area. So data information, but if we have a as-built hazardous layout drawing, we can make HAC drawing very easily. Here, this is example, for example, gasoline tanks, and there are 5 gasoline tanks. This is the layout which is made, and these are dikes. It could be in between, or dike are not shown here. If we are making all 5 tanks in one dike area, or there's a one dike, I'm not so sure. Like one tank is separate, 4 are separate. So if we take those storage tanks as a AutoCAD drawing, and then accordingly, we need to know the property of those fluid. It was a gasoline. The grade of release is primary. Flash point is minus 43 degrees Celsius. Auto ignition temperature is 243 degrees Celsius. Fluid category C, petroleum class 1, temperature class T3, UFL 7.6%, then LFL limit 1.4%. Now, for the inside the plant area, we have done zone 0 marking because there's a fluid inside the tank. So the dotted zone 0. Then next, this is the area which is about like a 3 meter or 2 meter as per the standard. We have marked as a zone 1. Then the areas basically outside zone 0, zone 1, these are zone 2 areas up to the dikes, right? So any installation which will be coming inside the plant, an electrical instrumentation equipment, it has to meet zone 0 requirement, then zone 1 requirement, and zone 2 requirements. If we have to make a one common drawing, this is a one common drawing where, like normally we also show equipment like a layout and equipment basically what you call it schedule. So as we know that these are the equipments inside the process plant area, what is their services, then accordingly we try to make the HAC drawings. So these are like how we make area by area. It's not difficult if you see it. Anybody can make it, but we need to have a basic knowledge and basic supervision. So before we go to selection and installation of E&I equipment in the HAC zone, we take question answers now. So let's have some interaction because we have covered 96 slides and we have covered the HAC part. The next part is how to select the equipment. So you can give the chance to the person to speak first to his question. Then, so as he should give his name.
Mr. Haider Ali Khan Suri, you have given permission to speak, sir. Can you please speak, sir?
Mr. Haider Ali Khan Suri is not available, maybe. His mic is mute. Okay. His question is, what is the reason that only diesel operated vehicles are allowed to enter in the live plant, not the gasoline operated? Basically, the diesel engine vehicles are operating at the compression ignition. They don't have any spark. Whereas gasoline engines are having, so that ignition source can also ignite if there would be any hydrocarbon inside the running or live plant. So that's why only compression engines are allowed inside the facility. This is the normal convention across the Middle East. And also the flame arresters are to be installed in the exhaust of the diesel engines as well. Okay, next question.
So next question is from Mr. Bernard. We have allowed you to speak. Kindly unmute yourself and ask your question. Mr. Bernard.
Okay, so I can read the question. What are the equivalent certification for each standard for electrical area classification? So see, if you are certified as per like IEC 60079, so it's a one internationally common standard. And then other certifications, if you need to follow, you can follow. But in general, it is not like we are not working in HAC zone. So HAC class certification is also applicable, but we are talking about the international standard that could be followed. The next question. Hazar Ibtisam Amor. Can you please ask your question?
Please,
Okay. in my company, we were used to classify chemical hazards according to NFPA. Recently, we were classifying them GHS. What do you think, sir, about this classification? See, NFPA is applicable as per American standard, and GHS I am not familiar. So for us, either NFPA or IP-15, there are two criteria you can classify the HAC area. Okay, thank you. Next question.
So next question is from Mr. Nadeem Ahmed. We have allowed you to speak. Kindly unmute yourself and ask your question, please.
So I can read the question. Sir, is E&I technician also involved in HAC? Yes. While using any equipment inside any electrical instrumentation equipment, whether it's a hand tool or the permanent apparatus, it should be like complying with the applicable HAC area. So it means that E&I technician should know which equipment he can carry in the applicable HAC area. So that is the correlation between HAC and the E&I technician task. Next question, Mr. Jahanzev Alam is asking, like, why NFPA 497 is difficult to use. It's my opinion. Like, I feel very comfortable using like IP-15, very easy to follow. And similarly, we have been using API 500. But if you go to the NFPA side, reading is somewhat difficult also. So otherwise, anybody can use if he's comfortable with NFPA 497 as well. See, the other question is from Mr. Abdullah. How can we determine where to use which standard? So this is defined by the country of residence. For example, like in America, normally API RP500 is applicable or NFPA 497, whereas in Europe, IP or EI15 is applicable. And other countries, it is basically as per their federal laws, like in UAE, IP-15 is normally preferred. And in Saudi Aramco, they are normally preferring API 505. So it is country to country. It's not we select as an engineer. Basically, we follow which standards are being used by that government and the operating companies in that particular country.
So next question is from Mr. Umesh Banker. We have allowed you to speak. Kindly ask your question. Mr. Umesh Banker.
Okay, I can read the question from Umesh Banker. What are the input document required for preparation of HAC? Okay, it's a good question. I think we should be listing those equipment, this slide in our presentation. So normally we need equipment layout drawing, PFD with heat and material balance, these two, and MSDS of the basically of the fluids which are being used in that facility. Three things important: equipment layout, number two, heat and material balance and process flow diagram, and number three, MSDS of the fluids which are being processed within that facility. Okay.
Okay, sir. So next question is from Mr. Fernando JR. We have allowed you to speak. Kindly ask your question. Mr. Fernando.
We go to the next question. What criteria is used to determine the extent of each hazardous zone? This is what we have been explaining. So each criteria is there, like zone 0 criteria is there, zone 1 criteria is there, and then zone 2 criteria is there. That has been presented in our presentation. See, there's a question. Mr. Roni Morta is asking, what are the primary differences between IP-15 and API 505 standard? Practically, no. IP-15 and API 505, not 504, are almost same. But there's a difference between API 15 and API 500 because IP-15 and API 505 are using basically the zone 0, zone 1, and zone 2 criteria, whereas API 500 is using division 1 and division 2 criteria. Okay, there's a question from Willie Santinta. Are MSDS still used? Are not they replaced by SDS in the year 2000? Yes, MSD is old terminology, which is called material safety data sheets, and now safety data sheets you can use either one because we need basically we need information regarding the process with reference to the diamond, the 4 categories, and that answer is used basically for the HAC classification, and number 2 for the data sheet of the electrical and instrumentation in the process area. Okay.
So next question is from Mr. Panagiotis Kalaikus. Can you please unmute yourself and ask your question?
Hello, do you hear me?
Yes, sir. You are the first person we are able to hear you.
Hello, thank you for the presentation. I come from Europe, from Greece. Here, 60079 is the main standard, so I would like to understand between all the standards, which is the more conservative one?
See, 60079 is for the selection and to meet the HAC applicable HAC area requirement. So this is the dominant standard, and it is the this standard is acceptable worldwide. So we will be covering this part in the coming slides, because this part is still yet to come, because now what we presented up to now, how hazard area classification can be done. Now, what is the effect of hazard area classification on selection of electrical and instrumentation equipment, for the preparation of their data sheet, for preparation of their specifications, for purchase, and from the vendor side as well, we will be covering next. Okay, sir.
Okay, thank you.
Thank you.
Okay, so next question is from Mr. Ronnie Morta. We have allowed you to speak. Kindly ask your question. Mr. Ronnie Morta.
See, if it's not available, I can read the question. What are the differences, different hazard area classified under IP-15 and IP-505? We have been presenting that both are more or less same. IP-15 and IP-505 are same, but 500 is having division 1 and division 2 terminologies. Okay, let's go to the presentation next, and we'll take the question answer at the end one more time. So gentlemen, please keep writing your questions in the question answer window, and we will be giving you a chance to read your question, and also we'll answer live, and that would be at the end of the presentation. Now, the next part is selection and installation. Like if we have done, basically what we have done now, we have made the HAC drawing, and where all the zones, zone 0, zone 1, zone 2, as per API 505 or IP-15 have been done. And now what the use of this? Its use is if any electrical or instrumentation equipment would be installed in this particular area, so what would be the impact on them? So here, if we see that gas zone and dust zones are there, whereas we did not touch dust zone, like a zone 0, zone 1, zone 2, but dust zones are also there in the same standard, which are zone 20, zone 21 and 22. So is a one like exception we can say. So if there's a hydrocarbon or explosive dust, which is coming normally in PVC areas, maybe in cement plants or any other area where dust could also be there instead of hydrocarbon gases and liquid. So dust could also be an explosive mixture. So we have to keep in big mind, like it's not only IP-15 zone 0, 1, 2, there is also zone 20, 21, and 22. Now, like first thing is selection of E&I equipment in those areas, the applicable standards, like what we use, I will go to next. The selection and E&I equipment to be installed in the hazardous area cloud shall be based on the frequency, like this is the same on the hazard area classification what we have done earlier. Then additionally, the enclosure protection class also need to be evaluated. The standard which I normally follow is basically IEC 60079, which we call IEC explosion proof equipment. Then NFPA 70, normally called NEC. Then ATEX directive or ATEX 94/9/EC. These three terminologies are there. Similarly, if we say that IEC 60079, which is certification is accepted globally, this is one information where people might be interested. Now, there is a IEC 60079 certification is accepted for the equipment, not for the people globally. Then NFPA 70 NEC certification applies in the US. And then ATEX directive certification applies for the countries in Europe. Now, point is, this is not for the certification of the people, this is certification of the equipment in accordance with the applicable class of the hazardous zones. Then since IEC X certification is accepted internationally across several member of countries, we will institute the implementation methodology of hazardous area classification for E&I equipment based on IEC X certification. Hazardous area, the selection, installation, and maintenance of electrical and instrumentation equipment must be carefully managed to prevent ignition of combustible flammable substances in that particular area. Then, in order to select the appropriate electrical and instrumentation equipment for hazardous areas in accordance with IEC 60079, Part 14, Section 5, the following information is generally required. And like now we have forgotten, we have done hazard area classification. This slide is asking for the same information. Classification of hazard area, including the equipment protection level requirement where applicable gas, vapor, or dust classification in relation to the subgroup of the electrical equipment, temperature class or ignition temperature of the gas or vapor involved, minimum ignition temperature of the dust cloud, and minimum ignition temperature of the dust layer. So dust we did not cover, so anyway, keep in mind, so the properties are required for both the gas as well as the dust. Then intended application of the equipment, external influence and ambient temperature of that particular equipment. And this portion of the presentation is mainly for E&I engineers, because like a normal process engineer, mechanical or chemical engineer, we make hazard area classification and give all the input data to the E&I team, and they know what data they need to fill into the purchase specification and data sheets, and then accordingly how to interact with the manufacturer. So if you like ask me, I'm also not like good expert in this area, but we have a demarcation, work for the process engineer and safety engineer, and work for the E&I engineers. So this area is regarding E&I engineers. And if you are facing some difficulty, forget, because we are not normally involved in this kind of selection. This is a little complicated part, and E&I engineers are following it and they are trained. So if we spend some time, we can also understand, but it's not our day-to-day work. I'm talking about chemical engineer, process engineer, or the safety engineers. Now, here, if we see that relationship between equipment protection levels, like now technology is coming, like what kind of protection is required for a normal equipment? We call it EPL, equipment protection level. See, for gas and for dust. For zone 0, zone 1, zone 2, then zone 20, zone 21, zone 22. These three things I have added in this slide, but we did not explain earlier because we didn't cover the dust today. Because in 2 hours, we could not cover both. So here, here we need GA, and zone 1, we need GA or GB, and zone 2, we need GA, GB, or GC. Here, question is, GA can be installed in other 2 equipment, but GC cannot be installed in GA area, protection level, IPL level, highest level of protection, high level of protection, and moderate level of protection. Same is for the dust, DA, DA or DB, DA, DB or DC. Like higher EPL can be installed in the lower area, but not otherwise. Now, if here we see that selection of IPL, like the 6 slides are there, the electrical equipment and circuits can be used in locations requiring EPL, GA or DA if the equipment is either marked as a EPL, GA or DA. This is what I explained. Now here, GA means gas, DA is a dust. We have a intrinsically safe encapsulation, 2 independent type of protection, each meeting EPL, GB, protection of equipment and a transmission system using optical radiation and spatial protection. Similarly, the same properties are applicable on the dust side. And the requirement of these basically EPL, required equipment protection level, are defined under IEC 60079 Part 11, Part 18, Part 26, and Part 28. These are the for the and Part 33. These are the for the gas side, and others are for the dust side. Just like, please don't get confused. It's not we expected that we should remember it, because if we have to remember, then it would be difficult. But we need to know that one of the requirement for any E&I equipment in the HAC area, the first requirement would be what would be the EPL level, what would be the equipment protection level. That will depend upon like what kind of zone district that equipment is installed. Like I've gone to the previous slide, whether zone 0, zone 1, 2, and accordingly the EPL class is required. For dust also DA class is required. For gas GB or GC class is required. So this is defined like what kind of protection is required for the equipment EPL class, right? Now, if like there is a GB class, accordingly GB class, there is a type of protection code and applicable standard is there. Similarly, for the type DB, the same continuing. And then accordingly, we go for EPLs like this is what message is: the higher class can be used in the lower class, but lower class cannot be used in the higher class. The EPL class is important in the system. Similarly, for example, selection of EPLs, if we have to say GC, first we covered GA, GB, GC, and GC is saying that like intrinsically safe, encapsulation, non-sparking, and accordingly, these are the standard which is defining the requirement of that EPL class. So this also DC dust class is also there, and then accordingly, we need to know what kind of requirements are required to be met. Like here, encapsulation, protection by enclosure, pressurized enclosures, intrinsically safe, or special protection. Like if a junction box is there, what kind of isolation we need to implement there? If it's a motor is there, we know that in motor there's inside wiring, and so what kind of protection, what kind of enclosure is required so as it is not causing spark for the hydrocarbon around the pump or around the motor in that area. So first like selection is called EPL to protect in that particular hazardous area classification. Then second thing, type of protection methods. For example, if we have to see the next, what kind of protection we need. First is EPL, then the protection, mean flame proof, increase safety, oil filled, sand power filled, encapsulated, then pressurized or purged, intrinsically safe, non-incentive or special. Same example, like what kind of protection, these are explained here. Then like a flame proof means what? Like equipment is reversed, can stand an explosion from within without transmitting the flame to the outside. Equipment has a flame proof gap, zone 1. Motor lighting junction box is applicable. Then increase safety. If we have to say protection level, then equipment is very robust and components are made to a high quality, which is zone 1 and zone 2. Is also covering the motor lighting and junction boxes. Then oil field. Now, normally these are the like transformers, junction boxes, so switch gears which are installed inside the substations. The equipment is like equipment component are completely covered with a layer of oil. Heavy current equipment like transformers and switch gears. Similarly, sand powder field equipment component that are completely covered with a layer of sand or powder. These are electronics, telephones, or chokes. Then any method which can be shown to have the required degree of safety in use zone 1 is its certification states. This would be accordingly. Similarly, encapsulated, when the same definition is being explained here, equipment component of the equipment are usually encased in a resin type material. Then equipment is next pressurized purge. This is basically it is done if a junction box or if a control room like, then equipment is pressurized with a positive pressure. Gas cannot get into, because like there is a hydrocarbon outside, but that hydrocarbon should not go inside the basically junction box or the motor or that particular equipment. The equipment is pressurized with a positive pressure. Gas cannot get in for the air coming out, or equipment is purged with the diluting gas such as air. If air is used, it is ducted in from outside of the hazardous area. So analyzers, motors, control boxes, and computers, these kind of arrangements are made. Intrinsically safe, any arc or spark in that equipment has insufficient energy and it will not be acting as an ignition source in that particular zone. It is normally applicable on instrumentation like even mobiles and others. Then non-incentive. Then equipment is non-incentive or non-sparking, mean motor, lightning junction boxes, electric equipment. This is for zone 2. Similarly, like permittable ignitable gases, like the electrical equipment shall be selected in accordance with the gas group. The second thing is gas group from 2A, 2B, 2C. Like in 2A, acetic acid, acetone, ammonia, butane, and like propane, gasoline, methane, and toluene, xylene, methanol, propane, and so on. Then group 2 is the gases plus diethyl ether, ethylene, ethanol, methyl ethyl ketone, propane. Then group 2C is group 2A and 2B gases plus acetylene and hydrogen. Now, the gas group, now selection according to equipment grouping, electrical equipment shall be selected in accordance with the below table. For example, the location gas vapor 2A, 2B, 2C, 3A, 3B, 3C, and then permitted equipment in group, like which are applicable in that particular area can be used. Where electrical equipment is marked indicating suitability with a particular gas or vapor, it shall not be used with other gases or vapor without a thorough assessment being carried out. So the gas group is also EPL, then the level of protection, then the gas group has to be identified as well. So this electrical is becoming a little bit difficult, but don't worry, we don't need to do it. It will be done by the E&I experienced engineer when they will be filling the data sheet as per the use of equipment in the respective HAC area. Next, like selection according to the ignition temperature of the gas. For example, like whatever gas is available there, the surface temperature of the equipment should remain below that, right? And similarly, the electrical equipment shall be so selected that the maximum surface temperature will not reach the ignition temperature of any gas present in that area, the T3, T4, T5. Similarly, if the marking of the electrical equipment does not include any ambient temperature range, the equipment is designed to be used within the temperature range of -20 to 40 degrees Celsius. If the marking of the electrical equipment include an ambient temperature range, the equipment is designed to be used within this range only. If the ambient temperature is outside the temperature range, or if there is a temperature influence from the other factors, for example, process temperature or exposure to the solar radiation, the effect on the equipment shall be considered and measure taken and documented. Here, the symbols to be for the temperature class marked on the electrical equipment have the meaning indicating in the below table. For example, T1, T2, T3, T4, T5, T6, we studied earlier also. T6 mean the surface temperature should not exceed 85. T1 mean the surface temperature should not exceed 450. And outside also allowed temperature class of the equipment mean T1 to T6. And the first class equipment can be used, like a lower class can be used upper one, but upper one cannot be used in the lower one. Where, for example, T6 equipment can be used in basically T1, but T1 cannot be used in T6 or even T2. So this is the range, like the temperature, the equipment should not be creating a heat which can create like a ignition in that particular area. It is also applicable on the engine of the surface of the engine chamber, or any hot surface in that area should not be able to create temperature more than this class, which is defined by the applicable HAC class. Now, electrical equipment shall be selected and or installed so that it is protected against external influence which could adversely affect the explosion protection. For example, extremely low or high temperature, solar radiation, pressure condition, corrosive atmosphere, vibration, mechanical impact, friction or abrasion, wind, painting process, chemical, water and moisture, dust, plants, animals, and insects. So we have to consider all those, like the protection class and the equipment temperature bearing capacity should not be affected by the external factors. Then items of the personal equipment which are battery or solar operated are sometimes carried by the personnel and inadvertently taken into the hazard areas. So this is normally what we see, that like any like people we were used to listen that like don't keep your phone on near to the petrol station. And similarly, if we are going to the process area, if any phone is with us, any battery operated equipment is with us, that should be either intrinsically safe or we should not take in the process areas. So there are standard rules. So it is like conform to the recognized type of protection appropriate to EPL, equipment protection level, gas dust group, and temperature class requirement. Three things are there: EPL, gas dust group, and the temperature class requirement, or be subject to risk assessment, or to be taken into the hazardous area under the safe work procedure. So three things are important, what we studied up to now: EPL, equipment protection level, and up to what gas or dust it can withstand will not cause fire or explosion for that, and temperature class, so is not igniting that. So here, if we try to, now we have come to a point where like for like any engineer who is not like electrical and instrumentation, like any layman, what three things we need to comply with like HAC area. If I go back, if I have to remember three things: EPL, gas or dust protection, and then the temperature, three things. Okay. Now here, if we see that HAC symbol, or it could be like IEC 60079, it's telling me equipment marked as equipment marker 2G. HAC only is applicable, right? Then I will go to IEC further down. So then it is saying that type protection, EPL, type protection, explosion, then gas group 2B, temperature T4, and GB is equipment protection level, EPL is there. So three things: gas group, temperature, or level of protection. 2B, T4, GB. Similarly, if you take typical equipment marking for dust atmosphere is same, like equipment marked ATEX only, type protection, XTB, then 3C, dust group, T1, 35-degree temperature class, and DB. So practically, we are worried about these three things. Gas group is what, temperature class is what, and this. And then accordingly, if the equipment is explosion proof. So if we try to remember, we can remember. But this is like when we go, why we need this, why we need to understand. This is the problem now. Like when hazard area classification is made, we try to verify. Now, what is the use of hazard area classification? Like what would be the type of equipment we would be installing in those areas? And there is also one more work, and a lot of inquiries are coming nowadays, like third parties or inspection companies or engineers are asked to come and survey our facilities and make sure all our electrical and instrumentation installations which are made in the process area are matching with the applicable HAC drawing. First of all, HAC drawings are up to date. Number two, look at the equipment. It means we need to look at the equipment schedule or list of the equipment, and then try to see that in which zone which equipment are installed, and if those equipment are meeting the applicable requirement which are indicated in this table. So mostly we are not dealing in hydrocarbon as a dust, so we have to applicable these: gas group, temperature class, and equipment protection level, and then explosion proof nature. This we need to remember. And here same thing is defined in a matrix way. What we need to see, for example, non-sparking, explosion protection, like explosion protection. 2 mean device group, underground or all others, above ground, underground or all others. Then category, zone 1 for the basically gas, and zone 2 also for gas, zone 21 for dust, and zone 22 also for the dust. Then explosion proof atmosphere mean G for the gas, if you go here, and D for the dust. Then explosion protected equipment, we have type of protection for the EPR, this type of protection. Then explosion group and explosion subgroup, these are 2 for the gas and 3 for the dust. 2 for the gas, we have a 2A, 2B, and 2C, and dust is 3A, 3B, 3C. Then temperature class, maximum T, like we already went through this, T6 is 85 degrees C, T1 is 450 degrees C, depending upon what kind of like temperature can be potentially bearable in that area. Equipment protection level, G or D dust, like this is our first slide is what we remember. So these tables for each equipment we need to fill 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 things are required to be answered for each equipment, right? So don't worry, it is step by step. When you will start like looking at the specification of that equipment, and you will start understanding as you will practice. Typical like IEC marking on of EI equipment for hazardous area. If you see here, this is one of the equipment installation is there, right? And here assembly of one of the transmitter, X, DB, EB, IA, GB, 3B plus H2, T5, GB. These all are explained here, right? Now here, what is the EX explosion protected? DB flame proof with D with level of protection B. EB is increased safe. E with level of protection B. Then IAGB mean square bracket. This is a square bracket. Associated apparatus intrinsically safe with level of protection A. Overall application is because of the insert max for equipment protection level GB. GB is here, right? Then group 2B additional including hydrogen. Then this is the 2B plus H2 is there. Then T5 is the maximum surface temperature, mean T5 100 degrees Celsius. This is a T5. Then GB is the whole assembly has EPL GB zone 1. So this way, this equipment is selected for that particular hazard area and applied, and this information is available on the nameplate and also CE marked if applicable for the European Union. Then if we take the example of a motor, you will find also like the same table EXD2BT4GB, and it also flame proof motor. And then if we have to find that this data is also available, like the details, like what the properties and how it's being assessed and what would be the characteristic in that particular area. Similarly, if I show you another example, another motor, the name data is there, like again here, LCI 09ATX 2023, and then 3GB here, like XE2C3 CT3GB, this motor 3, motor number 2. Another motor also, EXNA2C T3GC. If we make the summary of this is a further specification and the other data. And then if we try to make the comparison, type of motor protection, first one is flame proof enclosure, increased safety, the non-sparking, the code D, E, and NA is there. Ingress protection is IP-55 for all. Insulation class of the motor, which is applicable in the motor, is F, and temperature rise class is B, and efficiency class is IE2. And EPL would be separate basically for this. This is for the motor internal like a safety. And then if we see these are like if we have to make equipment list in for the instruments available in any area. So here, so we make the list of those equipment and instrument tag number as per the SAP hierarchy. Like here, installation, discipline, parent tag, equipment type, manufacturer, model, service, then IP protected and area classification. So this way we try to look at the applicable like safety class of those particular explosion proof equipment. And as a data sheet also you will find the nameplate data explosion proof, like here the has like IEC 60079 is printed on the nameplate by the Rosemount. So now, like what we tried up to now, the hazard area classification, and after hazard area classification, we saw the effect, like how the electrical and instrumentation equipment are selected and how their like a protection class, gas, the surface temperature, the EPL level are defined, and then accordingly the nameplate, that information is basically printed and specifications are also updated. So by all the tests and certification is done as per that applicable class, and then accordingly that applicable class equipment is installed into the respective HAC area. So this is the basically use of the hazard area classification and its impact on the basically selection of instrumentation and electrical equipments. So here I will be a little fast because it's a case study. So hazard area classification conducted for a specialized independent terminal providing bulk storage, handling, and related services to oil and petrochemical industries. The primary objective HAC in the study was to identify location within the terminal where flammable substances or combustible dust could be potentially create explosive atmospheres, potential risk associated with the area containing flammable liquids and chemical, and ensuring the proper installation and application of tools, equipment, and electrical appliances. Utilizing a zone-based classification approach, the study assessed the presence and frequency of explosive atmosphere. The zones were categorized as zone 0, 1, and zone 2 for gases and vapors in accordance with EI-15 and API 505 standards. So scope of study, collect and review the latest available document and HAC drawings, conduct the site visit to observe current HAC practices, identified, incorporate the plant modification, perform gap analysis with EI-15 standard and current HAC drawings, highlighted deviations and provide recommendation to update the HAC drawings, consolidate existing and new HAC document in line with EI-15 standard, brief the updated HAC requirement to client management, provide a native file related to HAC study. So then client services, for example, product storage and what they are doing, product storage and handling, ship loading and unloading, ship discharge and bunkering, ship to ship and pipeline transfers, then inter-tank transfers, product circulations, tank truck loading and unloading, fuel additive injections. Like this is the plant layout where we have the berth, pump stations, storage tanks, truck loading gantry, and compressed air and nitrogen plant. This is the plant, and this is the sea and jetty where the ships are coming for the loading. Methodology, identification of flammable materials, determine source of release, determine extent of release, determine zone where explosive atmosphere occurs, size and shape of zones, rationalize merge overlapping areas with the same zone, determine the equipment protection level, properties of explosive atmosphere group and temperature class. Then assumptions, regular maintenance of the facilities being done, handling of the liquid at 40°C ambient temperature is being done, storage tanks maintaining atmospheric pressure, pipeline designed as per ASME 31.3 standard, one storage tank handling multiple fluid during its life cycle. Area classification should be based on the most volatile fluid anticipated. No major spillage or pools forming in the tank, in storage and tank truck area. Then exclusion of the ship tankers from the classification. Then assumption continued, ventilation is enclosed areas assumed to not fail. This is important. Like ventilation is always working in the closed areas. Procedure ensuring pig receiver and launches are isolated and vented before opening. All the tanks and equipment will be live and working unless specified in the report to be out of service. Storage tanks for the transfer oil is fully sealed and there is no vapor emission from the tank through any vent under normal conditions. Now, petroleum storage as a product point of view, total petroleum tanks 33, external floating roof 11, internal floating roof 22, total storage capacity of the storage tanks in the facility is about 920,000 cubic meters. Chemical storage tanks, total chemical storage 10, a total storage capacity of the chemical is 27,000 cubic meters. Then fluid category class 1, 2, and 3, petroleum class 1, class 2, and class 3. Then source of release, external floating roof tanks, natural ventilation, natural vents, then internal floating roof, mechanical as well as natural vents. Source of ignition, hot work during maintenance work inside the bund area, a dike area, lightning and generation of static electricity near the tank area. Then HAC zone, floating roof, zone 1, zone 2, as we showed earlier, the space within the tank shell above the roof classified as zone 1, the area above and around the tank shell for a distance of 2 meters classified as zone 2 and should extend at the height of the bund to the bund wall as shown in the figure. Like here, this is the figure what we used, like this is the zone 0, then this is the zone 1 area, and here is also zone 1. Zone 0, the ullage area, above the tank farm and the roof, fixed roof. This is the zone 0 is applicable on the fixed roof. The ullage area inside the tank is classified as zone 0. The area 3 meters surround the vents on the roof is classified as zone 1. Then the area from shell extended till bund is classified as zone 2, shown in figure 2. If we go to the previous picture, here, this is the example picture taken from the standard. It's not actual. This is standard. Here, this is the zone practically 0. It is a fixed roof. Then there should be, this is zone 2 practically. And zone 1 is missing here, not applicable in the particular figure. So this is the area, other one in the like a fixed roof tanks where we have all three zones, zone 0, then zone 1 and zone 2. Also example, it would be applied practically on the drawing other side. Then here, pump station, the pump station handle both petroleum and chemical products. there are two pump stations in the terminal, main pumping station, chemical loading pumping station. To handle the white product, there are 6 main cargo pumps and 5 stripping pumps that can be connected to any main tank line. For other petroleum product, there are 2 cargo pumps. Petroleum class 1, class 2, 2, class 2, 3, 2. There is more than one type of product at any time in the pumping station. So the area classification was done based on the most volatile anticipated. Source ignition, the electrical equipment such as motors, junction boxes, cranes, and lights, hot work during maintenance, and tool powered by electricity. Source of release, the header, top flange, header vent, and process instrument vents will act as a primary source of release in the manifold area. The headers and telescopic tubes are source of release during the changeover of the header for product alignment and maintenance activities. Flammable vapors from flanges or joints may leak, and there will be considered secondary source of release. Then HAC zone, the main petroleum pump station is located below grade and has a shelter on top, can be referred as an open pit. The area inside the boundary of the pump station is classed as zone 1 because there is significant pipe work and congestion in the area. The equipment installed consists of telescopic tubes, flanges, connections, and hence free movement of air not possible. The inside of the pump is classed as a zone 0 inside the pumps, and zone 2 will be applied to an extent of 3 meters horizontally and 1 meter vertically for the pumps at grade level. The typical diagram for zoning of the pump as per AP-505 is shown in figure 03. The figure will be coming. So this is just the pump as we are showing, compressor or pump up to 3 meters outside the pump is a zone 2 basically. Then HAC zone, the hazardous area for process vent is marked per the typical zone marking AP-505 for the process vent in non-enclosed areas like this. This is the vent up to 3 meters, we are taking as a zone 2, and up to 1.5 meters as a zone 1. Zone 0, zone 1, zone 2 is similar to IP-15 or EI-15. Then fire pump station 1 and 2, the fire pump station are located near the berth area. Fire pump station 1 has 2 diesel tanks of capacity 3,300 liters. The fire pump station 2 has the diesel tank capacity of 3,300 liters as well. Source of ignition, hot work during the maintenance, and static electricity generation due to lightning near diesel tanks. Source of release, the release from the diesel day tank can occur if there is an accidental release from the diesel day tanks. The diesel tanks are connected to the pump through pipes, joints, and valves. These can become a secondary grade release. So then the fire pump station have diesel day tank of capacity 3,300 liters. The diesel day tank is a fixed roof atmospheric, and this picture would be applicable. Then the zoning for the diesel tank will be done as per fixed roof tank, and zoning in EI-15 and shown in figure 5. This could be like example taken from this. Then sample storage room, the located near the main office building and entrance of the facility. Container contains samples of the product for different clients. The storage of chemical in the sample room is very minimal. Source of ignition, no source of ignition inside the sampling room. However, the smoking area for employees is located very close to the sample storage area, which may be a cause of accidental ignition. Then source release, flammable release can occur if the flammable liquid are released due to accidental spillage when sample bottles are being stored. Duration and the frequency of flammable release in the sampling room is very less, as the bottles are not opened for inspection and proper handling procedures are available. Then, keeping in view the small quantity and low likelihood of the released flammable vapor in the sample storage room, the area was unclassified. Next, the maintenance workshop, the located near the office building and entrance of the facility. The primary operation is to repair the mechanical and electrical equipment of the facility on site. Hot work during welding and grinding, hot surfaces due to basically electric lamp and soldering air. This is the source of ignition. Source of release, flammable liquid are stored in small quantities inside the container for cleaning and repair work. The release of these liquid will be a secondary as they can only escape in accident scenario. HAC zone, keeping in view the small quantity and low likelihood of release flammable vapors in the sample storage room, the area was unclassified. Here, located near the main office and the maintenance workshop, the maximum sample size handled is less than 500 milliliters and can be classified as a medium scale operation. The instruments and small motors powered by electricity and the other equipment such as hot plates, heating mantles and ovens are all likely to have surface hot enough to be applicable of igniting some material that may be used. Source of ignition is here. Then source release, for example, as per EI-15 at laboratory scale, primary grade source of release of flammable vapor and gases is likely to be very small. The possible secondary grade source of release in many circumstances are numerous, or include like a breakage of glassware, loss of cooling to a condenser, main gas tap on an open bench, temporary pipe work between a gas bottle and other apparatus, then boil over of reactive mixture, spillage from poor handling techniques, storage container left open, and unsuitable disposal of the contaminated reagents. So, as per EI-15, laboratories are not normally zoned. However, safety measure and the precaution must be in place to avoid the risk of fire and explosion. These may include training in the technician to reduce the frequency and size of the source of release, for example, handling techniques that minimize the risk of liquid spill, appropriate use of like a fume cupboards to control primary or large secondary grade sources, a high standard of awareness of the fire risk and training in the actions to be taken in the event of spillage or leakage, means to isolate from a safe place any electrical equipment that is live in the event of a spillage or leak. A suitable equipment and training for dealing with the small fires. Close supervision of laboratory work where prompt actions may be needed to deal with the release any sort. And good ventilation is also required in the laboratories. Here, truck loading area. Truck loading area bay is an open area with the shelter on top. Fluid being handled are class 1, class 2, and class 3. This is the main area coming now. During loading in a particular loading bay, the engines and electrics of the truck are isolated. The trucks in the adjacent bay are allowed to come and go as per normal operation. Source of ignition, spark from the vehicle engines parked in the particular loading bay and the electrical equipment in the loading bay area, such as control panels and electronic flow meters can be a source of ignition as well. Source of release, the release of flammable material from bottom hose coupling during loading and unloading of the product can result in the secondary release. There is also possibility of secondary release from the vehicle vent and fill cover at the top of the tanker if products are loaded using fill cover at the top of the tanker. The equipment in the truck loading area, such as filter and strainers, can be a source of release during cleaning and maintenance. They will be regarded as secondary grade release. In the LPG unloading area, near the main pump station, the leak can occur from the couplings, hose reels, pump and relief valves on the tanker. So this was like as per EI-15 top loading tanker with tank top vent will have a zone 1 around them for 1.5 meter as shown in the picture. This picture, zone 1 at the area is shown, and there is a zone 0 inside the tanker. This example is used to guide. Then for bottom and top hose coupling connection on the road tanker as zone 1 and to be formed for 1 meter as shown in the figure here, like where the loading is taking place. Then for the bottom and top hose coupling connection on the road tanker, a zone 1 will be formed for 1 meter shown in figure this. Then when no vehicle is present in the bottom loading bay, then the hazardous area will be marked as shown in the figure, this one, like in the bottom side. Then when no vehicle is present in the top loading bay, then the hazardous area will be marked like this way. So this is the hazardous material table. Like if you see that, like what we are bringing here, the name of the chemical, their class, trade name, boiling point, all the LFL limit, ULF, all complete MSDS data is being basically filled, and then fluid category also is there. Then IP protection class is also there. So this way we have the name of all the fluids which data has been used. This is the same like HAC schedule, other chemicals. And this is the final drawing what we prepared. And here the applicable zones are shown as per the, this is zone 1 and zone 2. Zone 0 is not shown because zone 0 is shown if there would be a drawing like here. When the area where we can see the elevation. So conclusion, we have basically prepared the schedule and we have prepared the hazard area classification. Next thing is the preparation of electrical and instrumentation equipment list and their applicable class as per HAC. That is the secondary job, which is not being presented here. Then, what is the conclusion? Once the HAC drawings are prepared and what is required to be done, perform an activity in HAC, spark arresting tools, and the requirement of PTW should be fully filled. A vehicle entering the HAC should be equipped with spark arresters. Following discipline should be included in-house committee to monitor, verify compliance with the hazardous area classification during modification. Process engineers, electrical engineers, instrumentation engineers, HSC engineers, and experienced process engineer judgment is in visualizing leak scenarios and classifying hazardous area in the most crucial factor in the HAC exercise. This is a final recommendation. So normally hazard area classification deliverable is this kind of drawing along with the equipment schedule. Process chemical schedule as per the equipment. Right. So this concludes our discussion. Now we take the last part of the questions in next 5 to 10 minutes, and we can say bye-bye because we have already taken 10 minutes more than our planned time.
The question is from Mr. Muhammad Usman Asgar. Mr. Usman Asgar, we have unmuted, we have allowed you to speak. Kindly unmute yourself and ask your question, please. Muhammad Usman Asgar.
Can you hear me?
Yes, please proceed.
Yeah. Yes, sir. Thank you very much for the presentation. I just want to ask what is the best time to do this HAC and how these are related to the AIMS systems, like preferably about, I want to ask about the RBI inventory group looping and the stuff. Thank you.
No. The HAC process is implemented from the feed, detail engineering, and then procurement stage, construction and commissioning. So HAC is a process which is applied from the day one, like when you start the designing of your facilities for any purpose, because you need to have a proper layout, then you need to install all the electrical and instrumentation equipment to meet with the applicable HAC area. And HAC, the main objective is HAC, as we discussed earlier, to prevent any ignition source inside the process area. So HAC is a main critical part of any process safety system because it helps to prevent ignition sources or isolate ignition sources or prevent ignition sources. So it is HAC area has nothing to do with RBI, SIL. RCM is applicable because you need to develop preventive maintenance routines for the all electrical instrumentations which are installed in the HAC areas as per the applicable explosion proof class. I hope I answered your question.
Thank you very much, sir. Thank you very much.
Next question is from Mr. Nico Dutoit.
I can Nico Dutoit. Okay.
Hi, can you hear me?
Yeah.
Thank you for the presentation. I just want to know if you have various chemicals in your gas feed that have various states, like one might be explosive and at this point and at another point, how do you go about analyzing the system?
Yes, in that scenario, it was part of the presentation as well. When various chemicals or gases are there, we have to take the most volatile one, the worst one for the HAC. So as the other gases would be covered itself. Okay, sir. The most volatile has to be considered. Most reactive has to be considered as a priority. Okay, sir.
Thank you.
Thank you.
Yes, sir. Our next question is from Ms. Fariha Mushtaq. We have allowed you to talk. Kindly unmute yourself and ask your question, please. Ms. Fariha.
Okay, I can read her question. What is the TS, the standard, what is the standard reason behind not using mobile phone in the substation or the process areas? The question is mobile phones or any electronic device which may have a source of ignition or spark is not allowed in the flammable gas area or process gas area. That is the reason. The point is, since the mobile phone battery or spark generated by mobile phone can ignite fire, this is a fear. It may not be case in general scenario, but that is the precaution which is being taken for the ignition prevention of the process areas. Thank you. Next question.
So next question is from Mr. Saad Majid. We have allowed you to talk. Kindly ask your question. Mr. Saad Majid.
I can read that question. What is the classification for transformers installation? Practically, transformers are installed in the substation. In substation, as such, they are non-classified, but there is oil inside the transformer and switchgear. And similarly, you have a UPS system inside the substation. So we need to have a proper ventilation in that areas. Then accordingly, hazard area classification is applied to maintain proper ventilation so as hydrocarbon fluid does not accumulate inside the substation if there would be any leakage from the transformer or switchgear. And similarly, you know that hydrogen is produced by the UPS batteries, and proper ventilation is also required there, so as it's not making explosive mixture inside the battery room.
Next question is from Mr. Bernard Tolentino.
Hello,
Please
sir.
ask
Good
your question.
afternoon. Can you hear me?
Yes, yes.
Okay. In API 505, there are a certain number of types of facilities or different sections. For example, Section 9 is for the refineries and Section 14 is for the pipeline. Between two sections, they have a different approach for the area class for the flanges connection. In Section 9, it doesn't use flanges connection as sources for the area class. However, in Section 14, they are, for the pipelines, they are considering flanges for the area clusters list. Do we know what's, can I know the reason why they have a different approach?
See, I may not refer you to the exact section of that standard now, but see, in pipeline or piping, I think there's some confusion because pipelines are outside the process areas, and we don't anticipate there would be any electrical or instrumentation installation required along the pipeline route, because pipelines are normally called cross-country pipeline, or pipeline goes kilometers and kilometers. Whereas the piping, if flange connections are there, then the piping is within the plant area. We have to consider where the flange connections are coming. Nowadays, for hydrocarbon service, you don't put flange connection other than the connection of the piping with the equipment or with the pump or a vessel, or there would be any control valve. So in those areas where you have a flange connection, we have to assume that there could be a potential leakage of hydrocarbon, and we have to do hazard area classification, keeping potential leakage of hydrocarbon from the flange connection in focus. So that cannot be forgotten.
Okay, sir. Thank you. Another question is, I have observed that for the player tip, it is considered being unclassified. So may I know the reason why?
See, when we say flare is whatever the gas is going out that is already oxidized or burnt. So no, you don't have any hydrocarbon which will be burning further. That's why. And at that high temperature, like 1200 degrees Celsius, any electrical instrumentation equipment cannot sustain. So in that area, you are not installing any electrical instrumentation equipment, and HAC concept is not applicable there, because in the flare, fire is already there. Whereas in a HAC drawing, objective is to prevent the fire, right? If fire is already there, you can prevent the fire. Okay,
Agreed.
sir.
Agreed.
Thank you.
Last question, sir. I have seen an article showing that for the gas mixtures, they're adding the LEL of these different mixtures so that if the concentration is minimal, but the total concentration reaching their LEL can be contributed to the area class. So how effective is this kind of approach?
See, in general, see, you need to minimize the ignition sources and the area classification, as you could see our previous example on the laboratory, on the workshop. There is a debate like how much concentration is there, whether we have to classify the equipment or not. And that is basically decision by the owners, like what kind of risk they wish to take. However, the quantification of the potential releases we need to focus on, and we wish to minimize the possibility of ignition in that particular area. So it is a relative judgmental based, and it has to be done in a keeping IP-15 or API 500 or even NFPA 497 concept in mind. So I can leave that point up to there, because in this session we cannot do classification, but the debate is already there. And because if the old facilities which are installed without proper hazard area classification, if we try to do it, and if we have to replace the equipment, it's a big cost. And mostly operating companies are not interested to update it. Okay, sir.
Thank you very much, sir. Well understood.
Thank you, sir. Thank you.
Our next question is from Mr. Muhammad Javed. Mr. Javed, we have allowed you to speak. Kindly unmute yourself and ask your question.
Hi,
Muhammad
sir. Are you hear me?
Yes, yes.
Thank you very much for giving this such good presentation. Actually, I have a question. What if electrical spark happen storage tank, and how to prevent it?
See, this is not part of under HAC, but if you go to API 2610 or the relevant standard, like earthing is required, stray current prevention is required, and for the floating roof, there is a shunts which are made between the floating roof and the shell, so as there is no gap and no stray current is accumulated. So earthing, prevention of stray current by shunts, and these are the two main factors. And also you don't try to accumulate vapors at the floating, like on the top of the roof, and the potential for lightning from the skies is also one bigger threat. So, but earthing is a solution for that, and the prevention of stray current is another one. So that's why the fire scenarios are basically protected, and then firefighting system like a foam system and active firefighting system like water and cooling system is also applied. So these are the scenarios what we normally follow, but these requirements are not under HAC. These requirements are met under API 2610, which is the standard API standard for the tank terminals. Okay, sir.
Okay, sir. Thank you.
Thank you.
So next question is from Mr. Simakula Patrick. Please ask your question.
Thank you very much. So I have one question. During HAC, do we have to put RPE into perspective?
See, RPE, I do not remember this terminology because
respiratory protective equipment, yeah.
See, zone 0 is like you are installing any electrical equipment inside the oil or gas, inside the process plant, inside the equipment. Yes, I remember in a refinery, the salters are the one equipment where we have seen electric electrodes are installed to disassociate the salt. And for that reason, there are certain precautions for electrical installations. And since I am not electrical engineer, I'm sorry, I'm process engineer. So we do expect a special requirement because you are dipping the electrical equipment inside the oil. But we hope that since oxygen is not there, so the normal LFL is high would be there, and the chance of the fire would be lesser, because for fire you also need oxygen as a triangle. But whatever the precautionary measures are there, these are specified in the IEC 60079. Okay, sir.
Okay, sir. Thank you very much.
So that's it. Okay, we have taken already more than 20 minutes more than our scheduled time. So thank you very much. Some questions are not answered. Maybe we'll repeat this webinar because some people could not attend because of our 500 people limit in the Zoom. So we may repeat this session maybe after 1 month or so. But thank you very much for whoever attended it, and we are sorry the people who could not attend even after registration. Thank you and have a nice day.